Okay, so we're going to keep looking at higher degree polynomials, and in this video, we're going to be focusing on, well, what happens when they tell us something about the answers? They could tell us either something about one of the factors or one of the solutions, or something called zeros, which you see in this problem. So again, this is a fourth degree polynomial. I could very easily, if they wanted me to list all the linear factors, use the grouping method on this one. So let's see what happens when we do that, and then we're going to compare that to a different way of getting all the linear factors of this expression. So I'm going to look at this and say it looks like I have an x squared in common, okay? And when I remove the x squared from the first group, I have an x plus 2. Okay. And then my second group, I have a negative 9 in common, and it looks like I also have an x plus 2 left. And so when I regroup, I have an x squared minus 9 and an x plus 2. And then we have to remember that if any of your factors can be broken down again, you got to keep going. Since this is the difference of two perfect squares, I can turn this into x plus 3, x minus 3. And then again, the x plus 2 will come down as well. That's a part of my factors. So I end up with three factors using the grouping method, and we've essentially answered their question. List all of the linear factors. And so that is an option. Okay. We have another way that we could get the linear factors without having to use the grouping method, and sometimes this method will be required because the grouping method doesn't work. If we did a grouping method problem and, for example, the factors did not match, they weren't both x plus 2's, we need a way to handle four-term polynomials like that as well. So here's your second possibility. So I'm going to get rid of our grouping method. We know that we have an x plus 3, an x minus 3, and an x plus 2. Okay, so here's what we mean in the context of this problem to find the factors a different way. If I'm telling you that x plus 3 is a 0, right, this word 0, what it essentially is telling us is that I set some expression equal to 0, and the answer was x equals 3. So I'm wondering, what was that expression? And the answer is, well, that expression was x minus 3. Right? If I replace that question mark there with x minus 3 and said x minus 3 equals 0, my answer would be x equals 3. So I'm saying that x equals 3 is a 0 because x minus 3 was a factor. And if you notice, when we did the grouping method, x minus 3 was one of the factors. So I'm going to use that knowledge that x minus 3 is one of my three factors to get me that solution, this 0. And I'm going to use that to do a division problem. Okay, so I'm going to say, if x minus 3 is a factor, what I'm saying is divide this expression by x minus 3, and let's find out what happens. So this is a nice synthetic division problem. And I'm going to say, okay, let's set up synthetic division. Okay. Ooh, let me try that again. Let's set up synthetic division. All right, that's a better straight line. Okay. And I'm going to say, remember, what makes this turn into 0? This factor of x minus 3? Well, I'm going to say 3 does. Okay. So that 0 is essentially what goes outside of the synthetic division. And I'm going to say 1, 2, negative 9, and negative 18. I'm going to do a quick check. 3, 2, 1, nothing. And so that's good. I don't have to put any zeros into my synthetic. Okay, so we're going to just go through and do synthetic division. So I'm going to say 3, add down the column, and I get a 5. Okay, 3 times 5 is 15. Add down the column, and I get a 6. 3 times 6 is 18, and I get a remainder of 0. So if I write the answer to this division problem, it looks like it is x squared plus 5x plus 6 with a remainder of 0. Right, so I'm saying, all right, one of my factors was x minus 3. All right, let's get rid of this equals sign. X minus 3 was a factor, and I know that because they told me x equals 3 is a 0, is a solution. And then I have, after I divide away that factor, here's what I'm left with. This factors very simply, if you notice, 3 times 2 is 6, 3 plus 2 is 5. Right, I can say x plus 3 and x plus 2. And if you notice, those are the exact same three factors that we got using the grouping method. The x minus 3 was one that they gave me. And then after I divided that away, the remaining expression that was left over factored into the other two. So if I make a list of the expressions, I'm going to say the two that I got from dividing and factoring the result, plus the one that they gave me, that is the linear factor. So I'm going to say, here's your completely factored expression, x minus 3, x plus 3, and x plus 2, right? Which I got a completely different way than using the grouping method, right? But it essentially got us to the same place. So if they provide you with some information like one of the solutions or one of the zeros, you can use synthetic division instead of using grouping. And it's another option, and again, it's an option that sometimes will be required to use. Okay, so let's take a look at another example, or not. I'll cut that off.